In this video, we are going to be covering a very important and also a relatively new topic which has been added in Addmath, and this was tested the first time in May-June 2020. It was supposed to be tested, but then due to COVID, the exam never happened, and we know the story. Anyway, so this topic goes by many names. Number sequences is one, series is another, and APGP is another. APGP is basically short for arithmetic progression, geometric progression, and that's exactly what we're going to do in this topic. We're going to study progressions, and we're going to study how to find a certain term of that particular progression. We're going to study how to find a sum of a particular certain number of terms of one of these two progressions. Okay, so let's get straight to it. In this video, we are just going to familiarize ourselves with the two kinds of progressions. We're going to see what the key difference is between the two, and then so on and so on. And then in the next couple of videos, we're going to see how we can we're going to build up on more concepts, and we're going to look into that in detail. Okay, so let's say, so what I'm going to do is I'm going to write down a couple of terms, and then I want you guys to pause for a minute and see if you can identify a certain pattern and sort of predict or determine what the next couple of terms are going to be. Okay, so here's number one. So let's say you have 3, 5, 7. Now if someone asks you that following the same trend, can you identify what the next couple of terms or the next three terms are going to be, then I'm sure this is sort of like a no-brainer. So 3 to 5, you're going by adding 2. So what you're doing is you're adding 2, and then you're doing the exact same thing when you're going from 5 to 7. So we're going to continue on this trend, and we're going to add 2 to 7, so we get 9, and then we're going to add 2 to 9, so we get 11, and then we're going to add 2 to 11, so that we get 13. Okay, so let's take another example. So let's say you have 15, and then let's say you have 11, then let's say you have 7, and let's say you have, well, I wasn't supposed to give you the answer, but anyway, let's say here are the first three terms, and then I want you to follow the same trend and identify the next couple of terms. So we can see that we're going from 15 to 11 by subtracting 4, and then we're doing exactly the same thing when we're going from 11 to 7. That means from 7 to the next term, we will subtract 4. So 7 minus 4 is 3, and then we're going to continue doing the same thing over and over again. So we'll have minus 1, and then minus 4 again, so we have minus 5. Okay, so here's one example. Let's do one more example. So let's say you have minus 3, minus 5, minus 7, and let's say you have to find the next three terms. Okay, so how exactly are we going from minus 3 to minus 5? Well, we're subtracting 2. How are we going from minus 5 to minus 7? We're subtracting 2 again. So that means we'll continue doing the same thing over and over again for the next couple of terms. So minus 2, minus 11, and then minus 2 again, so we have minus 13. Okay, now let's say you have the first term, which is 2, and then the next term, which is 4, and the next term, which is 8. Now I'm going to give you one more term. I'm not going to give you three terms, so that you're able to identify or understand the pattern better. And let's say you have another term, which is 16, and your job is to follow the same trend and find the next three terms. Okay, so let's try and understand what the trend here is. So how exactly are you going from 2 to 4? Well, for starters, you might think that we're adding 2, and there's nothing wrong with that. You do get 2, you do get 4 when you add 2 to 2. But the thing is that that's not exactly the same trend that continues from 4 onwards. Okay, so let's try something else. So let's see how exactly we're going from 2 to 4. So 2 to 4, we can go by multiplying it by 2, or simply doubling 2, and then we can go from 4 to 8 by multiplying by 2 also, and then we can go from 8 to 16 by multiplying by 2 also. Okay, so that means we're going to follow the exact same trend, and the next term will be 32, the term right after will be 64, because that's what 32 times 2 is, and then the final term is going to be 128. Okay, so let's do one more example. Let's say you have 81, 27, 9, yeah, okay. So this time I'm just going to give you three terms. Okay, so how exactly are we going from 81 to 27? So if you have a calculator right now, I want you to divide 27 by 81, and you notice you will get 1 upon 3. So there are two ways to look at it. You can either say that you're dividing by 3, okay? So I can say that I'm either dividing it by 3, or you can say that you're multiplying it by 1 upon 3. And this is what we're going to stick to. We're going to stick to multiplying it by a certain term, which dividing by 3 is basically the same as multiplying it by 1 over 3. So that's what I'm going to stick to. I want you to think of this as if we're not dividing it by 3, as if we're multiplying it by 1 over 3, because the term is getting 1/3 every time. Okay, so what happens when you go from 27 to 9? So from 27 to 9, you're doing the exact same thing. That means you're multiplying by 1 upon 3. And then we're going to continue on the same trend. So 9 into 1 upon 3 is 3. And then 3 into 1 upon 3 is 1. And then 1 into 1 upon 3 is 1 upon 3. Okay, now let's collectively look at these progressions and see which one's which. Now here's something that I want you to really focus on. Whenever you're adding or subtracting a certain term, in order to get to the next term, and that's what's happening consistently, then it's an arithmetic progression, okay? So one way to identify or distinguish between an arithmetic progression and a geometric progression is basically, in an arithmetic progression, you have something that's called common difference, okay? So here's what we're doing. In an arithmetic progression, you have something which is called common difference, and we elaborate this and write it like this, that the difference between consecutive terms is the same, and this difference is called the common difference, and we denote this with a lowercase d, and that's what arithmetic progression is in short. So difference between consecutive terms. So what I mean by that is you can pick any two terms, they have to be consecutive, and you'll notice that the difference is the same. So if I pick 11 and 13, I know that the difference is 2, and that's what the common difference is. If I pick 7 and 9, I know that the difference is 2, and that's what the common difference is, okay? So what I'm going to do is, with every progression that we have written, I'm going to write down the common difference, and I'll write it in purple so you can distinguish. So for the first progression, the common difference is 2. Yeah. Now for the next progression, the common difference, since you're subtracting 4 every time to get to the next term, the common difference is -4. And for the third progression, the common difference is -2, since that's what you're doing in order to get to the next term every single time. Now, one thing that you must know about arithmetic progression is that the difference between the third term and the second term is the same as the difference between the second term and the first term. And this could apply to any set of consecutive terms. For example, it could be the 5th or the 4th, it could be the 100th or the 99th. Since as long as they're consecutive, the difference will be the same, and that difference, fellas, will be equal to the common difference. Okay, so that's arithmetic progression for you. Now let's talk about what geometric progression is. Now, the progression number 4 and 5 are basically examples of geometric progression. Now let's see what makes a progression a geometric progression. So let me just drag this here to make some room. Yep, there you go. Okay, now in a geometric progression, you don't have a common difference. Instead, you have something we call a common ratio, and that is that the ratio between consecutive terms, basically the preceding term divided by the preceding term, okay, and that ratio is the same. Okay, now let me tell you what I mean. So what I mean here is, in simple terms, that the ratio, first let's write this down, between consecutive terms is the same. So that means, and that by the way is called the common ratio, which is denoted by lowercase r. And you can determine the common ratio by taking any set of consecutive terms, and you can do T2 upon T1, which basically means the second term divided by the first term, and this will be equal to the ratio of any other set of consecutive terms, okay? And this value will be equal to the common ratio. So let's apply the same thing in the progression number 4 and 5. So in progression number 4, since we were consistently multiplying by 2, the preceding term by 2 in order to get to the preceding term, so the common ratio was equal to 2. And in progression number 5, since we were consistently multiplying by 1 over 3 in order to get to the next term, the common ratio over here is going to be 1 upon 3. And this is this fellas is basically the key difference. I mean, these are the key differences between an arithmetic progression and a geometric progression. So just to summarize it for you, in an arithmetic progression, you are consistently adding or perhaps subtracting a term in order to get to the next term. In a geometric progression, you are consistently multiplying, or in some case dividing, but I want you to think of that as multiplying also in order to get to the next term. And in arithmetic progression, we have a common difference. In a geometric progression, we have a common ratio. So that's all for this video. I will see you guys in the next video, where we'll be studying arithmetic progression in a lot more detail. So yeah, that's all. See you in the next video. Until then, take care. Bye-bye.